Hello again and welcome to our STEAM project number 19, featuring the ESP32CAM integrated module. This lesson is part of our Sherpa level series, designed for the somewhat experienced STEAM teacher. In today's project, we are going to look at the fundamentals of object recognition and machine learning. This project is also a solution project in support of SDG 11, Sustainable Cities and Safe Communities. My name is Peter. I am the founder of Educomondo and a certified STEM instructor and course designer. Object recognition is one of the most popular applications of AI on microcontrollers, also called edge AI, because the microcontroller is at the edge of a network and it is our link with the real world filled with objects. The goal of this lesson is to prepare the setup to capture and classify objects with a new and special microcontroller, the ESP32CAM. This device is made by the company Espressif Systems, and it is very well known for its compact form factor and wireless integration. So today we will have a walk around of the ESP32CAM and its programming board. We will see how to set up the ESP32CAM in the Arduino IDE as AI Thinker. We will install the libraries to take pictures of two objects to feed into the platform Edge Impulse. We will create an account on Edge Impulse and understand the workflow. And lastly, we will deploy the Arduino library created by Edge Impulse on the ESP32CAM. Here is the ESP32CAM with the accompanying ESP32CAM MB. The CAM, of course, refers to the built-in camera. It has a standard 2 megapixel camera that is used, and it is called the OV2640, made by the company OmniVision. The ESP32CAM has 16 pins, which is less than the microcontrollers we have worked with so far, but it only has to serve a limited number of functions. The pins are labeled with very small print on top of the microcontroller. Next, it has a built-in micro SD card writer, and it even features a small LED flashlight. Turning the ESP32CAM around, you will find the Wi-Fi module with the built-in antenna. There is an interface for an external antenna, but for our projects we will not need one. You have probably noticed that there is no USB connection. To program the ESP32CAM, you need an external programming module. The ESP32CAM MB is your best choice as it has been designed to work seamlessly with the microcontroller. You can simply connect the two and you're ready to go. Let's turn to our laptop, and for this lesson we are going to use the Arduino IDE. If you haven't installed this development environment yet, go to the Arduino website and download the latest version that corresponds with your operating system. Once the download is completed, simply double-click on it and the installation will start. It is a very straightforward process. The installation will take a couple of minutes, and once that is finished, go to the left side and select the icon of the board's manager. In the search box, type ESP and hit return. Then select the version ESP32 by Expressive Systems. In the output of the IDE, you can watch the progress, and once it is completed, go to the top and select Other boards and comms. A dialog window will appear, and in the search box, simply type AI. From the list that appears, select AI Thinker ESP32CAM. That is the board version that we will need throughout this project. At this stage, you can connect the ESP32CAM simply to check whether the system recognizes the device. Go to the bottom right corner to check whether the board appears with a COM port assigned. If not, in the top menu, you can go to Tools and then check Port. The next step is to install a library that will facilitate the capturing of pictures of objects, which will be uploaded in the Edge Impulse AI training model. This time, go to the Library Manager and in the search box, type Eloquent. Now select Eloquent ESP32CAM by Simone Salerno. Make sure to select the latest version and hit Install. Once again, this may take a couple of minutes. But with this, we have done the heavy lifting to prepare the ESP32CAM. Because we're almost ready to capture pictures of our objects to train the model, now is a good moment to show you the ESP32CAM holder. You can include this as a 3D tinkering assignment, or you can also simply download the STL file from the Tinkercad link that appears now in the video. It is a very simple design that allows for some up and down movement. Because the camera is mounted on its connecting wire, it is quite flexible to bend in the required angle. I think now all is set to start our photo shoot. For a photo shoot, we will need to build a miniature studio. You can, for instance, paint the inside of a large cardboard box, or you can construct a neutral background with some sheets of white paper, as I have done. It is important to have a neutral background to make objects stand out clearly. Avoid excessive shadows, but make sure that the objects are adequately lit. You can choose any object that you want, but be aware that this is a relatively low quality camera, and it is best to take objects of a reasonable size with distinctive features. We have taken a robot and a rubber duck. If you have not already done so, connect the ESP32CAM to your laptop. Go to the top menu and select File, Examples, and scroll down to the Eloquent ESP32CAM, Collect Images for Edge Impulse. That will appear as a sketch in the development environment. The purpose of this quite complex sketch is to create a local web server that will be used to capture a large series of pictures. With large, I mean around 75 to 100 pictures for each object. Before we upload the sketch, we need to make 3 small changes to the program. First, we need to insert the name of the wireless network that your laptop and the ESP32CAM will be connected to. Secondly, add your password of the Wi-Fi network. And thirdly, add the following line of code: camera.pinout.aithinker open and close the rounded brackets, and of course do not forget to end with a semicolon. And we do that where the program asks to insert your camera model. Once all this is done, you are ready to run the sketch. In the serial monitor, look for the final lines as a result of running the sketch. This should show the IP address of the local web server. Copy this address and paste it in a browser. If in your IDE you see a number of error messages, do not panic, but rerun the sketch. Sometimes it takes more than once to get the results that you really expect. Once you have the IP address and it's copied into your browser, then you should see a square image that is taken by the ESP32 cam. And underneath it, you see a push button that says Start Capturing. So let's go to our mini studio, and the first step is to make a couple of pictures of the empty background. This will help the system to distinguish between objects and background. Click on the Start Capturing and stop the sequence after around 15 images. Beware, this goes fairly quickly. We save the images and give the folder a recognizable name, for instance, background. Now we place the first object. Make sure that the camera remains in the same position all the time. You can, fixate the camera with some tape or sticky buds. Push the button Start Capturing again and take a number of short bursts of pictures. Again, 5 to 10. Stop, turn the object just a little bit and start again. Repeat this process till you have around 100 pictures from different angles. Give them a recognizable name such as robot. And we repeat this with the next object, the duck, and we'll give it the obvious name, Ducky. As a result, you will now see 3 compressed folders that we need to decompress, we need to unpack. Delete the compressed versions to avoid mixing them up. The folder contains all the pictures that you have taken, now each file starting with the prefix that you have provided. If you want, you can copy these folders to a place on your own choice, like in your project folder. We are almost there. We are now entering a very crucial step in the process. We are going to start the model training in Edge Impulse. In our next step, we are going to go to the Edge Impulse website and log in. You will have to create a login just following the different steps. And as you can see, I already have created one object, so I am going to create a new one. And I'm going to give it the name RoboDuck. It's a private one. As you can see, with the free version, you only get 2 private projects. So I just want to create it as a new private project. So it takes a small while. And as you can see, we are getting into the home page, the starting page. And the first thing that we want to do is to add our data. Since we have our data, we just need to upload it. And you can see there are a number of options. We can select a folder or individual files. We can have a manual split between training and testing. And also the labels can be inferred from the file name. I'm going to select the folder because we have folders with our images. And the first one I'm going to upload is the backdrop. 16 files. And you just have to click on upload the data. And it asks us immediately if we are working on an object detection project, which of course we do. And as you can see, it goes very quickly to upload the files because the files are quite small. The next folder we are going to upload are our images of the duck. 78 files. Upload the data, and you can see it goes really very, very fast. Once those are completed, we can go to the next one, the remaining images of the robot. Upload again, 53 files. And there we go. All of the files have been uploaded, so there is no need to combine the files up front. Actually, I would not recommend to do that because sometimes the files or the different files, yes indeed, they will be presented to you in the labeling part as mixed duck and robots, and that's very difficult to do. So here you can see that we can have a look at all of our files. We can click on a sample to load. So this is the robot that we have photographed. Sorry about that. And in case that certain images are not correct, for instance, you can delete them here. Next, we go into the labeling queue, which is probably the most important part of the object recognition and the machine learning, because this is where we are going to label each and every single of our objects, of our pictures. And the first thing we do is we are going to look for the backdrop, and we do not give it any label, we just do save labels, but we are not giving it a particular label till we get to our duck image. And here is our duck image, and this is where we're going to start giving it a label. Now we are going to actually have to label each and every single image that we've made by dragging a box around it and giving it a label. Here we call it duck. We set the label, and as you can see in the red window, the red box, it shows duck. And now each and every single image we will have to adapt until it is completed and we can get to our robot. Now, to change the window, to change the box, you can go to the left upper corner to move the box in its entirety, or you can go to the lower right part where you can make it smaller or bigger. The aim is to be as precise as possible. So you can see here that it's quite outside of the box. So we're going to make it a little bit smaller. And each time we save the label, once again, it's a little bit too small, and we are going to save the label. Also here, we are going to move it first a little bit to the right, and then we are going to make the box smaller so that everything fits perfectly. The idea is to, the idea is to be as precise as possible and to have as little background as possible. So this one is really outside, so we have to place the duck in the red window or in the red box. And yes, we have to do that for all of the items. So 112, 111 items left. So it will take a small while in order to complete this job. So let me quickly go forward and see where we are when we get into the robot. So here we are. You can see that we are now with the robot. It's still labeled as duck. It certainly is not a duck. So we will have to change the label by clicking on it. And we just have to remove duck and call it robot. Set the label, and you can see that the box has changed color in green. And now we have to do exactly the same for the remaining 52 images of our robot. As you can see, there is more background with this particular object because of the open arms and the open legs. So I am very curious to see how that will turn out later on in the process, whether the system can easily make the distinction between the object and the background. So once again, it's the same, making it a little bit smaller, a little bit bigger, move it a little bit to the left, to the right, to make sure that it fits as precise as possible. Once again, I will speed up the video. until we have like 8 items left. And we are lucky that the last ones are more or less the same, so we don't have to make too many changes. Once it's finished, it says no items in the queue anymore. So the whole labeling has been completed. So that's, I would say, from a human perspective, that is really the heavy lifting. On the left side, you can see that we can now go into the impulse design because our data acquisition has been completed. And the first thing we need to do is what is called to create an impulse. The first view that you get, you don't need to change anything. We just take save because it's the standard setting that we receive, being able to have this as a free version. The image data, you can change the image width and image height. It's 96 by 96. I'm not going to change it, just leave it the way it is. Then we need to add a processing block. We only have the choice of one processing block, and we only have the choice of one learning block, which is the object detection learning block. So very simply add it as in the flow here that we need to do. And then we just need to save this as an impulse as the next step, and it also says that it was successfully stored. And in the next step in our workflow after create impulse, we have the opportunity to actually check a little bit more on the images. And the first thing in terms of the parameters is that we can either go for RGB or grayscale. Now we have color pictures, so let's just stick with RGB as the standard parameter. And otherwise there is not that much that we need to do. There's something like DSP, which stands for digital signal processing. So that's really the link between our images and the rest. After we have checked the parameters, we can now generate features. Also there we are not going to change anything in compared to the standard settings that we have received. So clicking on generating features, it's going to create an output. And as you can see on the left side, in the background, a couple of things are happening, and it's going to create features. It's going to generate features. Now this will take also a little while. So we are just going to let the computer, let the platform do whatever it has to do. And once that is finished, we will get back and look at those features. Once it's finished, you will see that it changes from no features generated yet into a nice visual on how those features are separated. And it will show you an interesting graph where the features that are related to duck and to robot, so the yellow, the orange and the blue ones, are nicely separated from each other. What this really means is that the object recognition will not make too many errors by making the distinction between the duck and the robot, because the features are really separated from each other. If your result is that these are scattered and that the blue and the orange ones are almost mixed against each other, don't panic. I have had some really nice instances where exactly that happened, but I still had some really good results. The next thing is, go to the object detection. Once again, we don't have to change anything on what is being proposed and suggested by the system. We are using the FOMO methodology, which is faster objects and more objects. Why? Because this is very much adapted towards using the Arduinos and using microcontrollers. So we can just save and train. And now the training model is starting. So you can see here in this view on the training output that it is creating a job on the system, and it is now going to go 60 times through all of these images, and at the end of it, it will be trained. It should be able to make the distinction between a robot and a duck when we present it to the ESP32. So here it started. It says epoch 00. Epoch is another way of saying a cycle of a complete cycle of a complete training. So all the way, so 4, 5, 6, all the way to 59, and then the system or the model will have been trained. Going once again to fast forward, because it will take a short while before everything is finished. So let's go back, and here we are again. All of the 60 epochs have been completed, and it is still finishing. It's converting a couple of things, so we just need to be a little bit more patient before we can go to the next step. And that next step is actually we go to the deployment directly. There are a couple of other things that you can do. If you're not happy with the results, you can retrain, for instance, the model. And the error message that you see here is because I was a bit too impatient, so the training output is still working, and you cannot go to the next step until everything is finished here. Now, in the meantime, we do see the performance of the model and the F1 score, which is actually a score between 0 and 1. And 1 is the absolute best. So this is almost 1. So it's 94.7%, which is a very, very good result. That there's a good distinction between the two objects. The one thing that you can see here is that the robot and the background do have a bit of an overlap, which, as you remember, I was already afraid of that because of the open arms of the robot. So let's see if everything is finished now, because now we can go to the deployment. And the deployment is actually really nice, and one of the main reasons why we have chosen Edge Impulse, because, as you can see, we can have an Arduino library as the output. Now that makes our life really, really, really nice, really easy. So we just have to select the Arduino, and it is going to build the model, and it's going to give us the output. It's going to give us a library that we can immediately use on our Arduino. So the model is being built. It may take a couple of minutes. Excuse me. But as you can see, it's already there. And it also gives you the suggestion or the hints and how you have to bring that library into the Arduino. You can see it downloads it immediately. And so let's go to the next step. Let's go back to our Arduino IDE and see how we can import it into our program. So here is our previous program where we have set the camera and the pictures. So I'm now going to check where the program is. So I go to Sketch and I'm going to include the library and add us a zip library. And it's under Downloads. And I'm going to take the last one that we did. So just open it. Of course, I will probably get a message that it's already there. Yes, it's an existing library. So I'm just going to click on yes. It says library installed. However, I had the experience that you may have to restart your Arduino IDE to actually have it in your system. So that is what I've done in the meantime. So I am going to examples and I'm going to check for the robotic inferencing. I take the ESP32 and ESP32 cam, and you can see it pops up a nice edge impulse library. And the only thing that I have to change now is to change the model, the camera model. As you can see, by default here, it's the model ESPI that is active. So that one I will have to change into a comment, and I have to activate the camera model AI Thinker with PSRAM. And you will see that the library is quite a complex sketch with a lot of information and a lot of programming. So it's really high level, but it makes our life so much easier to work with it. So let us upload this sketch, and once again it is quite big, so even uploading and compiling the sketch may take a couple of minutes, so be patient. It will pop up, and then we will be able to open the serial monitor and see what is happening. Let me speed up the video. Okay, so I have sped up the video, and as you can see, it started to work. And when it says leaving and also that hard resetting, that's a good sign. So let us now open the serial monitor, and immediately you can see that it starts to recognize the different objects in our little studio box. And as I am placing the different objects, even having the objects together, so whether it's the duck separately or the robot separately, it starts to recognize it. If I want to see whether both of them work, it also works if I place those two together. It will recognize both of the objects that we have trained the model on. And that's it for lesson 19. I am confident that you and your class found it useful and are eager to continue with the second part in lesson number 20. Bye bye for now.